After studying balancing of chemical equation, in this video we are going to learn the stoichiometry of chemical reactions. Now let us now go into the main stoichiometry. So I use this opportunity to just outline everything we are going to be learning: mole to mole calculations, mass to mass calculation, mass to mole to mass, stoichiometry involving molar volume, and the one involving acid and base titration. So those are the parts we want to cover, and those parts will go a very long way. And the last part that is also very important is the part that has to do with what? With the limiting reagent, limiting and excess reagent, and excess what? And excess reagents. Now all these are very important in stoichiometry. Mole to mole, remember that in a chemical reaction you have reactants. I have reactants reacting together to give us products. If I say mole to mole, what does it mean? It means that you are doing calculations that involve mole of reactant to mole of product. It's either they tell you to find the number of mole of products from the number of mole of reactant, or the number of mole of reactant from number of mole of product. They'll be relating these two, and that is it. They'll be relating these two. And stoichiometry have this thing in common. You see, with mathematics, what is that? If I say one pen costs 20 naira, then 5 pen will cost how much? Stoichiometry have to do with this. How will I relate it to stoichiometry? Check this out. If I have reactants A reacting together to give me B, if I say 1 mole of A was able to produce 3 mole of B, who can tell me 5 mole of A will produce what? If 1 mole of A can give me 3 mole of B, then 5 mole of A will give me what? Cross multiply. 5 times 3 will give me then 15 mole. Do you see that? Stoichiometry have to do. This is what they call mole to mole relationship. Now, next one, we have mass to mass relationship. Here, we will not be having mole, we'll be having some things in grams. So you have some certain mass of the reactants, grams, to give me what mass of the product, also in gram. That is, you'll be dealing with gram. And pay attention, everybody. You see, this is just the way to calculate anything in gram. Always convert it to mole. What did I say? Always convert it to mole. Whenever you see grams in stoichiometry, convert it to mole. And don't forget, we'll be using this formula a lot. Remember that mole equals to what? Mass over molar mass. This is what we will use to convert mass to mole. Whenever, for example now, if they give you 10 grams of the reactant, you use that 10 grams there, you calculate the molar mass of that to get your mole. We've learned mole concept already, good. We will do that. So after, if you get your answer in grams, if you want to calculate it to mole, what will you do? If you have mass, how can you, like if you have the mole, for example, how can you calculate mass? This is it. From this formula, this is the same formula I'll be using. If I cross multiply, I will have mass equal mole times molar mass. You see that? That's very important. Mass equal mole times molar mass. Please keep that in your mind. So that's that for that on this. So next one, you can have mass to mole. So this one can be grams, this one can be mole. It depends. And we also want to learn the one that have to do with what? Molar volumes. That is the one that is dealing with gases. That is, I can tell you that, oh, if this product is a gas now, for example, I can say, okay, 10 mole of this reactant will give me how many cm cubed, how many volume of P. So you can be asked to do with volume also, is possible. So we have acid and base titrations. So when we get there, you understand that. And we have what we call limiting and excess reagents. Okay, so I should not say everything in this slide. So let's move to the next slide to understand the concept one after the other. So I'll be starting with what? Mole to mole calculations. Now, let's look at the first question under mole to mole calculations. Study this question carefully. In the equation, how many moles of hydrogen are produced when 8 moles of ammonia decomposes completely? You see, in stoichiometry, you just needed 2 things to calculate. What is that? Note what you are given and what you are asked to find. In this question, they said, how many moles of hydrogen are produced? That means that what? You are asked to find hydrogen. Note it down. You're asked to find what? Hydrogen. This is what you're asked to find. Now, what are you given in the question? They say when 8 moles of ammonia decomposes completely, you are given 8 moles of ammonia. Good. Now, you are dealing with these 2 things. You see this nitrogen, neglect it. That's stoichiometry for you. Now, before you start solving, balance this equation. How do we balance it? Check it out. You see, if you observe, I have 2 nitrogen here. To balance it up, I will have to put 2 here. The nitrogen is balanced. Then if you look at hydrogen, hydrogen is 6 here, and I have 2 here. If I put 3 here, then hydrogen will be balanced. Now I'm done balancing the equation. Now after balancing the equation, the next thing is to solve the question. Now observe this is what mole to mole calculation. How will you do it? You see, look at the 2 things you are dealing with. Neglect nitrogen, you are not even using it. Now let's go. What do we do here? You see, firstly, look at the stoichiometric equation and relate the moles together. What am I saying? Check. I have 2 moles of ammonia. 2 moles of ammonia in the question. Are you there? Producing 3 moles of hydrogen. That is, look at the question and look at their stoichiometric moles and look at it. I have 2 moles of ammonia and that is producing 3 moles of hydrogen. I'm relating these two because those are what we need in the reaction. Good. Now 2 moles of this gave me 3 moles of this. Now the question is now telling you that 8 moles of ammonia will give you how many moles of hydrogen? Look at ammonia. This 8 mole will be under it. That is 8 moles of ammonia will give me how many moles of hydrogen? I don't know. I can say let that one be what? X. Simple. Then from here I can cross multiply. 2 times x will give me 2x equal to 8 times 3. I will just write my 8 times 3. Good. Then I'm looking for x. I will divide both sides by 2. Cancel, cancel. 2 here 1, 2 here 4. Therefore, x equal to 4 times 3, 12. That is 12 moles of hydrogen will be produced. And that is actually simple. That's all. Very, very simple, right? Good. Now just look at what you are given in the question and just move on. That's all. Now, next one. The next question is this. How many moles of water are produced when 5 moles of oxygen are used? Here, you are not given an equation. But as a science student, you should be familiar with the equation that produces water. That is, hydrogen and oxygen react together to give me what? Water, H2O. Before you proceed in this question, you have to balance the equation. If you check, 2 atoms of oxygen are here. I would like to balance that by putting 2 here. Then since these are balanced, if you look at hydrogen, hydrogen is 4 here. So I can also put 2 here for hydrogen, so to balance hydrogen also. So all the atoms are balanced. Hydrogen is 4 here, 4 here, oxygen is 2 here, 2 here. Good. Now, how do we now solve this question? Pay attention. Remember, it's stoichiometry. What did they give you? What are you looking for? They said how many moles of water are produced. You have to look for number of moles of water. When 5 moles of oxygen are used, then this is what you have. So hydrogen is useless in this question. Okay? Do you understand that? Good. Now, before you start solving, relate the moles together. Here, you have 1 mole of oxygen. If you don't see anything there, that's 1 mole. 1 mole of oxygen producing how many moles of water? 2 moles of water. Then, when 5 moles of oxygen are used, that is, if I now have 5 moles of oxygen, what do we now have for water? I don't know. Cross multiply. X times 1 will give me x equal to 5 times 2 will give me what? 10 moles. Therefore, 10 moles of water are produced. That's all. So that makes sense. It means if 1 oxygen can give me 2 for water, therefore 5 of oxygen will give me 10 for water. So that's that for that. Now, let's look at another style of stoichiometric question, which is mole to mass calculations. You see, under stoichiometry, before you begin to solve, observe the question and see the pattern. I'm sure that by the time you finish all the stoichiometry in this video, you will have been familiar with different patterns of questions. So whenever you see a question, you just identify the pattern and just use my technique, that's all. Now they said, how many grams of potassium chloride are produced from 10 moles of potassium and excess chlorine gas? Okay, what do we do here? Firstly, write the equation. If you observe, they said, how many grams of potassium chloride are produced? It means that what potassium chloride have to be in the product side because it has been produced. Then produced from what? From potassium and chlorine. Now let potassium and chlorine react. Potassium is K. Remember, potassium from our elements, compound and mixture. Potassium is the monoatomic element. Chlorine is diatomic, that's Cl2. Okay, so you can't write chlorine as Cl, it's diatomic. Then when this and this react, remember they'll give us potassium chloride. This is this potassium chloride. Now, let's balance the equation as you know. I have 2 chlorine here. To balance that, I'll have to put 2 here for the chlorine. Also, as we have 2 here for the chlorine, this 2 is also affecting potassium, so you have to put the 2 here. Therefore, this equation is balanced. You can see that. Now, after that, let's solve the problem. They said, how many grams of potassium chloride are produced? Remember in stoichiometry, I told you that know what you are looking for. So we are looking for this. And look at what they give you. What they give you in this question, they gave you 10 moles of potassium. You see, if you say this word excess chlorine, in fact, if you say this word excess in general, that thing they are saying, you must not pay attention to it. Because in stoichiometry, we don't deal with excess reagents. Are we together? Anything in excess is not pay attention to. We don't even pay attention to it at all. Are we together? Take note of that. So they give you 10 moles of potassium. So it means that what? You are dealing with potassium and potassium chloride. Now, remember this question is asking you how many grams of potassium chloride. It means that you have to find the mass of this. But we don't know. Firstly, let's solve it and get the mole. From the mole, we can get the mass, very sure. Now, let's go. From this problem, 2 mole, let me use another color, please. 2 mole of potassium gave me 2 mole of potassium chloride. So that is, you can see that what the moles are equal. 2 to 2 is equal. It means that whatever this mole give you will always be equal to whatever this mole will give you. That's the meaning of this 2 to 2. Or if you see 1 to 1, if they are equal, okay? Now let's go. 2 to 2. Therefore, 10 moles of potassium will give me what? 10 moles of potassium will also give me 10. 2 to 2 means that they are equal. So 10 will also give me 10. So I have 10 moles of potassium chloride. 10 moles of potassium chloride will be produced. But remember, the question did not ask me to find mole. It asked me to find grams. But remember, to find grams, which is mass, don't forget, recall that mass is equal to mole times molar mass. Now, what you need to do is that calculate the molar mass of potassium chloride. Don't forget, potassium chloride is potassium. They will give you that K is 39 and Ca is 35.5. So let's go. Let's calculate that. What do we have? 39 plus 35.5. So let me use my calculator. What would that give me? Okay, so we have 39 plus 35.5. We have 74.5. That's 74.5 gram per mole. Therefore, to now get the mass we are asked to find in the question, the mass is equals to mole. What is the mole? We have 10 times molar mass. What's the molar mass? 74.5. Therefore, this will give me 745 grams. That is the answer. You can see the technique is that calculate the mole first. Then from the mole, you will not get the mass by using this formula. Simple. Let's solve another question to make this aspect clear. Now, let's look at this problem. Consider the reaction. In this reaction, aluminium reacts with chlorine to give me aluminium chloride, and the equation has been balanced for you. They said how many grams of aluminium chloride? You are asked to find aluminium chloride. That is, you are asked to find the grams, which means you are asked to find the mass. So you are asked to find the mass of this. Let me put it here so you know what we are looking for. Would be produced with 2 moles of chlorine. Okay, looking at the equation, I have 2Al plus 3Cl2 to give me 2AlCl3. They said how many grams of aluminum will be produced when 2 moles of chlorine are with 2 moles of chlorine. Well, you have this and you're asked to look for this. So let's relate these two together. Remember, this is not needed since we are not even dealing with it at all. Now, remember in stoichiometry, look at what they asked you to look for and look at what you are given. If you can get the 2, you are good to go. Okay, what do we do here? Now, relate the moles first. Relate the moles. Now, 3 moles of chlorine is there. That is 3 moles of chlorine. Produce how many moles of aluminum chloride? 2 moles of aluminum chloride. Now, the question is now telling you 2 moles of chlorine will now give you what? Now, come here and say 2 moles of chlorine will now give you, I don't know, say x. Then cross multiply. 3 times x is 3x. Equal 2 times 2, so I have 4. From here, you are looking for x, divide both sides by 3. 3, you know, x will be equal to what? Let me just say I have 4 over 3 moles of aluminum chloride. I have 4/3 moles of aluminum chloride. Remember, the question did not ask you to find mole. The question asked you to find the mass. Are you there? Assuming the question asks you to find the mole now, 4/3 is the answer, and you get that in your decimal. But you want to find your mass. And remember, to find mass, what is the equation? Mass is equals to mole times molar mass. Now, we don't know the molar mass of aluminum chloride. I would love to get that. So aluminum chloride is what? Aluminum is 27, and then chlorine is 35.5. So I'll say 3 times 35.5. Remember, 1 chlorine is 35.5, so times 3, because I have 3 here. So what do we have? So let me get that to my calculator. Some people say, won't I do this with a calculator? Of course I can, but our time could be wasted. I'm coming. 35.5 times 3, then plus 27. That will give me 133.5 gram per mole. That's the molar mass. Now, after getting the molar mass, what do we do? How do we now get the mass? We say, therefore, the mass is equals to, remember, the mole we got was 4/3. That's 4/3 times, what is the molar mass? 133.5. So, therefore, what's now our final answer? Please give me a little time. So, we have 4/3 times 133.5. What would that give us? So, we have 4/3 times 133.5. So my answer is 178 grams. Well, your own could be approximately 178, because as we have changed this thing to decimal, 4/3 will give me 4 divided by 3 in decimal. That will give me 1.3333 and so on like that. So I just use my own directly here. That's why you can see I'm having a perfect number. But anyhow it goes. So this is my answer, 178 grams. I believe that is clear. So is there anything on the stoichiometry? I believe the answer is no. Just follow the pattern step by step to your expert. Thanks for watching. Now, we have this question. They said that if 12 grams of silver, Ag, were produced, how many grams of Cu, copper, reacted? Okay, solution. You see, we have this equation whereby we have copper reacting with silver nitrates to give me copper 2 nitrates plus silver. Firstly, before you even do anything, balance the equation. But firstly, if you observe, you see that from here, I have NO3 occurring how many times? 2 times, right? So that means that the NO3 I'm having here also, I should also put 2 there. Don't mistakenly do something like this, please. We don't deal with subscripts, we deal with coefficient. That is that 2 that is here. If I want to balance it here, you see the way I will do it. I'll put it here. So I have 2 NO3. But similarly, I'm also having 2 silver, because this 2 is also talking to it. So what will you do? You will now put the 2 here. Then that's balanced. Copper is 1, 1. That's balanced. Good. Now after that, what do we do? Now they said 12 grams of Ag were produced. So you have this one that was produced. So you are asked to find the number of this one that reacted. Now deal with the moles first. You know, we are going to deal with moles. But check something out. Whenever you are solving stoichiometric questions, please pay attention. You can see this one that we are dealing with now is mass to mass. Whenever you are solving stoichiometric question, wherever you see mass in grams, please convert it to mole before you do anything. Altogether, convert it to mole. Even before you start solving, convert it to mole. Okay, good. So let me first convert it to mole. Let me shift this one downward. Yeah. Let me convert it to mole first. Okay. So this 12 grams of silver should be converted to mole. Therefore, mole of silver. Remember, mole is mass over molar mass. What is the mass? 12. What's molar mass of silver? Silver is Ag, 108. And what would that give me? I use my calculator. So I have 12 divided by 108. That gives me 0.11 mole of silver. That's what I have. Good. So it means that if I now want to refer to this 12 grams now, I'll be calling it as 0.11 mole. So I can say if 0.11 mole of silver were produced, so now tell me the 2 things you are dealing with here. You are dealing with silver, and also what? You are asked to find copper reacted. So you are dealing with copper. Now from the stoichiometric equation, don't forget the pattern. The pattern remains the same. That is 1 mole of silver. 1 mole of silver gave me how many mole of So 1 mole of copper give me 2 moles of silver. Now 0.11 mole of silver that you have here, put it under silver. 0.11 mole of silver you have here will be produced from how many mole of copper? That's x. Are you there? Because you are asked to find copper x, and they gave you 0.11 mole of silver, 0.11. So from here, what do? We cross multiply. 2 times x is 2x equal 1 times 0.11 is 0.11. To get x, you will divide both sides by this 2 you have beside x. That's mathematics. X equal to, so 0.11, so if I do this divided by 2, what will I have? 0.056 mole. 0.056 mole of what? Of copper has been reacted. Now my answer is 0.056 mole of copper reacted. But tell me, did the question ask me to find mole? No. They said find the grams of copper reacted. It means that I will have to convert this mole to mass by saying this is what they asked me to find, mass. And mass is equals to mole times molar mass. So what is the mole I have here? 0.056 times what's the molar mass of copper? Molar mass of copper is 65. Then that's equal to times 65, 3.6. So my answer is 3.6 grams of copper. That's that for that. As simple as that. Now, they said from the equation, look at this equation here. Calculate the mass of potassium chloride. This potassium chloride produced when 100 grams of potassium trioxochlorate 5, that's KClO3, is decomposed. So you were given 100 grams of this. 100 grams of this. Firstly, you see, we would like to calculate the molar mass of each of these. It will be needed. So let's calculate the molar mass of KClO3. That will give me K is 39, potassium is 39, chlorine is 35.5. You'll be given in the question, don't be scared. Plus 3 times 16. So what do I have? So let me punch my calculator. So I have, no, that's 3 times 16 is 48. Good. Then if I add that with 35.5 plus 39, that will give me 122.5. That's 122.5. Good. Gram per mole. Also, molar mass of KCl. I will need them, so I'll calculate them. That's 39 plus 35.5. What would that give me? That's 39 plus 35.5. So that will give me 74.5. 74.5 gram per mole. So I've gotten them down. So from the equation, KClO3, don't lose guard and solve. This thing you see there means that what? It was applied to this to give us this. When you get to non-metals and you study laboratory preparation of oxygen, you will come across these equations. Now let's go. Let's balance. I can balance this oxygen. Remember, there's 3 here. I can put the 3 here for oxygen. 2 here. I can put the 2 here. I will have oxygen balanced. So 2 times 3 is 6 for oxygen. 3 times 2 is 6 for oxygen. So 2 KCl is here. So I would love to add 2 KCl here also. So I balance it 2 to 3. Good. Now, what do I do here? Pay attention. You see, firstly, you were given 100 grams of this. Convert this 100 grams to mole. Are you there? So mole of KClO3, that's 100 grams. Remember, mass over molar mass. I have the mass 100 divided by, what's the molar mass of KClO3? That's 122.5. So what would that give me? So if I punch my calculator, I have 100 divided by 122.5. What would that give me? 0.82 mole. I have 0.82 mole for what? For KClO3. Now let us now go. You see, we are asked to find this guy. Don't forget. Now from the question, 2 mole from the equation, 2 mole of KClO3 gave me 2 mole of KCl. You can see that what they have the same number of mole. Therefore, 0.82 mole of KClO3 will also give me 0.82 mole of what? KCl. It will be the same because their ratio are equal, 2 to 2. Whatever this one give you also be whatever this one give you. Okay? Now, after getting that, what do I do? You see that I've gotten the number of mole of what? Of KCl. I've got the number of mole of KCl, but the question did not say find the number of mole of KCl. It said find the mass of KCl. Therefore, the mass is equal to mole times molar mass. So what is the mole? The mole is what? 0.82. The molar mass of KCl is 74.5. So let's calculate that. Times 74.5. What do I have? I have 60.82 grams. That's that for that. So whenever you have mole and you want to calculate mass, this is what you will do. Okay, good. So whenever you are solving stoichiometric question, always solve in mole, then you convert to mass. That's all. Now let's look at this problem on mass and volume relationship. This is the question of stoichiometry that have to do with volumes altogether. And remember, the molar volume of a gas at STP is 22.4 dm cubed. That is, 1 mole of a gas will occupy 22.4 dm cubed at STP, at standard temperature and pressure. If anyone asks you what's the volume of a gas occupied at STP, 1 mole will give me 22.4 dm cubed. Now let's go. The question said, what volume of dry oxygen gas is measured at STP? You are dealing with oxygen. Then will be produced from the thermal decomposition of 6.4 gram of potassium triacylchloride 5. Will be when this is thermally decomposed. That is, this is the equation. If by this equation, please have it off hand for now. Okay, have it off hand because questions usually come on it very well. So when KClO3 is decomposed, we have KCl and oxygen. Now, before you solve, always remember I told us that whenever you have grams in a question, under stoichiometry, convert these grams to mole. So I will say mole of KClO3 given in the question is what, remember, that is the mass, 6.4 divided by the molar mass. Molar mass of KClO3 from the previous question, we got that to be 122.5. So for my calculator, I have 6.4 divided by 122.5. What would that give me? That would give me what? 0.05 what? Mole of KClO3. I have this of KClO3, good. Of KClO3. Now let us now move to the equation. Now from the equation, what did you notice? Pay attention to something. Remember that we are relating KClO3 to oxygen. From the equation, you observe that, oh, I have 2 moles of KClO3 producing 3 moles of oxygen gas. Now, after that, 0.05 mole of KClO3 will give you how many mole of oxygen gas? Try to calculate this. What will you have? I'll have, if these 2 multiply this x, you have 2x equal, this multiply this, you have 3 times 0.05. To get x divided by 2, so what would that give me? So from your calculator, you have 3 times 0.05 divided by 2, 0.075. So I have 0.075 mole of oxygen. Now see what I have here. But remember, the question did not ask me to get the mole of oxygen. I was asked to get the volume of dry oxygen. I'm asked to get the volume of oxygen. Now remember, always remember something. You see, to get the volume of oxygen, the straightforward way to do it is that what? Multiply this mole you got here by the molar volume of a gas occupied at STP, and that is 22.4 dm cubed. And what would that give me? I'll have times 22.4 dm cubed, so that will give me what? 1.68 dm cubed of oxygen was produced. If the question wants you to find the volume of oxygen in centimeter cubed, then multiply this by what? 1000. Multiply this by what? 1000. So that is it. So you can observe that someone might ask me that why is it that I got the why is it that I multiplied this by 22.4 dm cubed? Why? It's very simple. Remember that what? 1 mole of a gas occupied 22.4 dm cubed. Therefore, 0.075 will occupy how many? This times this. You can see that. So whenever you have the mole and you want to convert it to volume, just multiply by 22.4 dm cubed, and that's all. So thanks for watching. Now let's look at this question. We have this. They said consider the following reaction equation. C2H4 This is reacting with this to produce this and this. They said the volume of oxygen required at STP. See, the volume of oxygen required at STP, that is, you have to find something, you have to find the volume of oxygen at STP. Now, here you have to find the volume of oxygen, we don't know that. That will be required to burn 14 gram of ethane. This ethane, C2H4. So you got to burn 14 gram of this. So this one you have what? 14 grams of this. So firstly, find the mole of ethane. So what do we have? Say what? Mole of ethane. Mole of ethane is equal to what? Remember, mass over molar mass. So if you look at 18, that's C2H4. What's the molar mass? I have 2 times 12. Carbon is 12. Then hydrogen is 1. You know, this is 24. 24 plus 4, that will give me 28 gram per mole. Now, the mole of ethane is mass over molar mass. So I have mass. The mass of ethane is 14 gram. Over molar mass of ethane is 28. Right? Good. So I will punch my calculator. That is 14 divided by 20. That's 0.5. That's half now. That's 0.5. Yeah. That's half. Now, so I have 0.5 mole of ethane. That's 0.5. I've gotten that. Now, if you observe the question, you see from the equation above, what do you observe? 1 mole of ethane reacted with how many mole of oxygen gas? Check. 3 moles of oxygen gas. 3 moles of what? Oxygen gas. Do you see that? That is, I'm saying 1 mole of ethane reacted with 3 moles of oxygen. Now, 0.5 mole of ethane that I've calculated, 0.5 mole of ethane will give me how many mole of this? That is x. If I cross multiply, x will be equal to x times 1 is x. 3 times 0.5, 3 times half will give me what? 1.5. What's half of 3? 1.5 mole. Now I've gotten 1.5 mole of what? Of oxygen gas. Remember, the question asked me to find volume. Don't forget, if you want to find the volume of oxygen, you multiply this mole 1.5 by 22.4 dm cubed. If they wanted to find your answer in cm cubed, just multiply by 1000. So I have 1.5 times 22.4. That will give me 33.6 dm cubed of oxygen gas will be required to burn 14 gram of what? Of ethane. That's that for that. Thanks for watching.